Here we are working on Chapter 4, Problem 3, and the problem reads as thus. A positron undergoes a displacement of delta r, and we're given the delta r, the displacement of the positron, as equal to 2 I hat minus 3 j hat plus 6 k hat. So that's the displacement of the positron. We know the positron's ending position to be r. Now I'm going to put an F here to remind me that that's the positron's final position, and that's equal to 3 j hat and minus 4 k hat. So we have the displacement vector, delta r, and we have r final, the final position vector. And we need to find the positron's initial position vector. We have to remind ourselves that delta r, the displacement vector, is equal to, delta r is equal to the final position vector minus the initial position vector. And we can handle this in 3 dimensions. We know that the displacement along the x component is 2, so we have 2 I hat, and that will be equal to the final position. Now notice in r final we don't have an I hat component, so we assume that we are initially at 0 I hat. Now we subtract the initial position along the I hat direction, so minus r I hat. And what we end up seeing is that the initial position along the x direction of the particle is given as r I hat is equal to minus 2 I hat. We now do the same thing for j and k. For the jth component, we know the displacement to be minus 3 j hat, and that's equal to the final position of the particle along j, which is 3 j hat minus r along the j component. This is the initial position of the particle, and we find that the initial position of the particle is equal to, my cell phone goes off, and that's equal to 6 j hat. I'll leave you guys to do the kth component, but it's the same method. The displacement vector along the kth component will be equal to the final position minus the initial position, and you should get that the initial position vector for the particle is equal to minus 2 I hat plus 6 j hat minus 10 k hat. And that's it.